Okay, so here's another system of equations we can solve using Gaussian elimination, and we want to get this system of equations in row echelon form, and we're going to use the three elementary row operations to do that, which those operations are just: you can switch any two rows you want to, you can multiply a row by a non-zero number, and you can add a multiple of one row to another row. Those are the three things you're allowed to do as you try to get the system into row echelon form. Row echelon form is when you have all the equations in this kind of stair-step way, where the first equation has all the unknowns in it and the constant, and then nothing below that x. Okay, and then the second one will have y and z in it and a constant, and nothing below that y. And then the last equation will just have the z, and it'll look like stairs. That's why it's called echelon. So anyway, let's get started. So the first thing we want to do is make it so that every equation, the only equation that has an x term, is the first equation. Okay? So to do that, we need to, well, let's go ahead and number our equations: row 1, row 2, row 3. All right, so we want to cancel the x's in the second two equations. All right, so to do that, we could add the opposite of the first equation to the third equation, and that would cancel the x in the third equation. So that's what I'm going to do. I'm going to say negative r1 plus r3. And that's going to be, r3 is going to be this new equation. r1 doesn't change. r1 stays the way it is. So x minus 3y plus z equals 1. That's still the way that is. And then the second equation doesn't change. 2x minus y minus 2z equals negative 1. And then the third equation, here, let me clean that up a little bit. The third equation will be the sum of negative r1 plus r3. So negative x plus x is going to be 0x. The opposite of negative 3y, which is positive 3y, plus 2y is positive 5y. Negative z minus 3z is negative 4z, and then negative 1 minus or plus negative 1 is negative 2. So that's my new third equation. So my third equation now doesn't have an x term in it. I don't want an x term in the second equation either. I only want an x term in the first equation. So now I am going to do that, I need to cancel out that 2x, so I'm going to add negative 2 times the first equation to the second equation and replace the second equation with that sum. All right, so negative 2 times the first equation, add that to the second equation, and that will make those x's go away, because you'll have a negative 2x and a positive 2x. So that'll make the x's cancel out. All right, the first equation doesn't change though. We're not doing anything to change the first equation. We're changing the second equation. Whatever this row is, that's the one that gets replaced, the second thing. So negative 2 times r1 plus r2 is going to replace r2. So negative 2x plus 2x is 0x. Negative 2 times negative 3 is positive 6. Positive 6y minus y is going to be 5y, so plus 5y. Then negative 2z minus 2z is negative 4z. That goes there. And then negative 2 minus 1 is negative 3. And the third equation stays the same. All right, so we have eliminated the x term from the second equation. All right, so we're good to go on our first stair step. The first equation is the only one that has an x term. Now we want the second equation to be the only one with a y term. So we want to cancel the y term from this third equation. All right. Well, in this situation, you see what happens when we try to do that. We're going to get something that doesn't always happen. It's going to show us that this equation is inconsistent. The system of equations is inconsistent. Okay, because what we would want to do is we'd say, okay, well, I don't want that 5y in the third equation because I want the third equation to just have a z term. All right, so I'm going to multiply the second equation by -1, so negative r2, and add it to the third equation. And that'll cancel the y's. All right, so first equation stays the same. And the second equation stays the same. And then the third equation, I'm going to add negative 5y plus 5y is going to give me 0y. And then positive 4 plus negative 4 is going to give me 0z. And then negative 3 becomes positive 3, minus 2 becomes 1. So you can see in that third equation you have 0 equals 1, and that is not true. 0 does not equal 1. We know that. So this system of equations is inconsistent. You would say no solution.